Welcome back. Let's practice solving equations of the form ax plus b equals c. All right, so first up we have the equation 3x plus 1 equals 13. And for all of the examples in this video, what we want to do is solve the equation and check the solution. Okay, so we're going to solve for the variable in the equation and then plug our answer back into the equation to see if it is the solution, to see if we did our work correctly. All right, and so to solve an equation of this form, where we have a constant times a variable plus another constant equal to another constant, what we want to do is start by getting the variable term by itself. We want to isolate the variable term by getting rid of the constant being added to it. So what we can do to get rid of that constant is add the opposite of that constant to both sides of the equation. Or in other words, we're going to subtract 1 from both sides. So if we do that here, and I always like to draw a divider below the equal sign to help visualize the two sides of the equation, because whatever we do to one side of the equation, we must do to the other. Otherwise, you will change the solution to the equation, which we don't want to do. And so drawing this divider, I think, is helpful at the beginning when learning to solve equations, so that you can see the two sides visually and remember to do the same operation to both sides of the equation. Okay, so we're going to subtract 1 from both sides, leaving us with 3x plus 0 equals 12, right? 1 minus 1 is 0, and 13 minus 1 is 12. Okay, so what we're left with is 3x on one side and 12 on the other, because 3x plus 0 is just 3x. So now our equation is 3x equals 12, and so we're almost done. In order to finish solving for x, we need to get rid of the coefficient, or the number in front of it, in this case 3. So to get rid of that coefficient, what we can do is divide both sides by that number, right? What we can do is divide both sides by 3, and 3 divided by 3 is 1, so you would get 1 times x, but x times 1 would just be x, so we'd have x equals 12 divided by 3, which is 4. And so x equals 4 is the solution that we found here for this equation, but let's check it. Let's see if it is true. If we check our work, we're going to plug 4 in for x in the equation. So we'll have 3 times 4 plus 1 equals 13. And so simplifying, 3 times 4 is 12. So we have 12 plus 1 equals 13. And 12 plus 1 is 13. So we get 13 equals 13, which is true. X equals 4 is the solution to this equation. Let's take a look at another example. Next up, we want to solve this equation, 4y minus 5 equals 15. And so in this case, our variable is y. That's what we want to solve for. And so to do that, we want to begin by isolating that variable term. We want to get 4y by itself on this side of the equation. So what we want to do is add the opposite of the constant being added to that term. In this case, we have negative 5, and so we want to add positive 5 to both sides of the equation. Okay, so if we do that here, we're going to add 5 to both sides. Negative 5 plus 5 is 0, so we get 4y plus 0 on this side of the equation, and then 15 plus 5 is 20. Okay, and then 4y plus 0 is just 4y, so we have 4y on one side and 20 on the other. And so to solve for our variable of y, what we need to do is get rid of that coefficient of 4, which we can do by dividing both sides by 4. And so 4 divided by 4 is 1, so you'll have 1 times y, which just gives you y, and so y will be equal to 20 divided by 4, which is 5. Okay? So we found y equals 5 as a solution to this equation, but let's check it. Let's make sure that we solved the equation correctly. Checking our work, we want to plug 5 in for y, so we'll have 4 times 5 minus 5 equals 15. Simplifying, 4 times 5 is 20, so we have 20 minus 5 equals 15, and 20 minus 5 is 15, so we have 15 equals 15, which is true. And so y equals 5 is the solution to this equation. Next up, we want to solve this equation, 4 minus 3a equals negative 2. And so in this equation, our variable is a. That's what we want to solve for. And to start solving for it, we need to first isolate that variable term of negative 3a. So what we want to do is get rid of the constant on this side of the equation. To do that, we want to add the opposite of that constant to both sides of the equation. So we want to add -4 instead of +4 to both sides. Or really, you can think of it as subtracting 4 from both sides of the equation. That's what I'm going to do here. We're going to subtract 4 from both sides. And so 4 minus 4 is 0. So we have 0 minus 3a. And then -2 minus 4 is -6. All right. And now we have -3a is equal to -6. And then to solve for a, what you want to do is get rid of that coefficient. So you want to divide both sides of the equation by that number in front of a, the coefficient. And so if we divide both sides by -3, -3 divided by itself is 1. So you'll have 1 times a, which is just a. And -6 divided by -3 is +2. So we get a equals 2 as the solution to this equation. But let's check it. Let's make sure that it really is the solution. We want to plug that value of 2 back into the equation. So we're going to plug it in for a right here. We'll have 4 minus 3 times a, which is 2. And that should be equal to -2. And so simplifying, 3 times 2 is 6. So we have 4 minus 6 equals -2. And 4 minus 6 is in fact -2. So we get -2 equal to itself. The equation is true, which means that a equals 2 is the solution to this equation. Okay, let's move on to another example. For this example, our equation is 0 equals -21 minus 3m. And so this time around, our variable is m. That's what we want to solve for. And so to do that, we have to start by getting rid of that constant term being added to that variable term. In this case, that constant is -21. So what we want to do is add the opposite of that number, which means we want to add +21. Okay, so what we're going to do is add 21 to both sides of the equation. 0 plus 21 would just be 21. So that's easy enough. But then -21 plus +21 would be 0. So we get 0 minus 3m. Okay, and so 0 minus 3m would just be minus 3m. And so we have 21 equal to -3m. And so then we can solve for m by dividing both sides by the coefficient of m, which is -3. If we divide both sides by -3, here's what we'll get. 21 divided by -3 would be -7. So we have -7 is equal to -3 divided by itself, which is 1, multiplied by m. So we just get m. So the solution here is -7 equals m, or you could read it as m is equal to -7. Okay, either way, we found that -7 is the solution to this equation. But let's check it. Let's make sure we did our work correctly. If we plug -7 in for m, we'll get 0 is equal to -21 minus 3 times -7. And -3 times -7 would be +21. So we have 0 is equal to -21 plus 21. And -21 plus +21 is 0. So we get 0 equals 0, which is a true statement. So that means that -7 is the solution to this equation. Next up, we have this equation, 1/2 b minus 3 equals 1. Okay, so now we're starting to look at some equations that involve fractions, so things can get a little bit more trickier, but the same solving process applies. Our variable term here is 1/2 b, so the variable is b, and we want to solve the equation by first isolating that term. So we need to get rid of this -3, and to do that, we can add +3 to both sides of the equation. So that will look like this. We're going to add 3 to both sides. So we'll get 1/2 b plus 0, because -3 plus 3 would be 0. And then 1 plus 3 is 4. So we have 4 on that side, meaning we have 1/2 b equals 4. Now, to solve for the variable of b, we would want to divide both sides of the equation by the coefficient, or the number in front of b. So we would want to divide both sides by 1/2. But an easier way to think about it is we can multiply both sides by 2. Really, 2 would be the reciprocal of this fraction. And if you remember, dividing by a fraction is the same as multiplying by the reciprocal, which is when you flip the numerator and denominator. So the reciprocal of 1/2 would be 2 divided by 1, which is just 2. So dividing by 1/2 would be the same as multiplying both sides by 2. Okay, but really, the way that I like to think about it is I want to get rid of that 2 in the denominator, so I'm going to multiply both sides of the equation by 2. All right, so if we multiply 2 by both sides, we'll have 2 times 1/2 b and then 4 times 2. 2 times 1/2 is just 1, so you get 1 times b, and then 4 times 2 is 8, so we get 8 on that side, meaning that we have found that b is equal to 8. Okay? So that is the solution we found, but let's check it. Let's make sure it is the solution. We'll have 1/2 times b, which we're saying is 8. So we have 1/2 times 8 minus 3 equals 1. And 8 times 1 is 8, divided by 2 is 4, right? We would have 8 divided by 2 minus 3 equals 1. But 8 divided by 2 is 4. So we have 4 minus 3 equals 1. And 4 minus 3 is 1. So we have 1 equals 1, which is a true statement. And so b equals 8 is the solution to this equation. Let's look at another equation that involves fractions. For our next example, we have 4/5 is equal to 1/2 x plus 1. Okay, so in this equation, there are two fractions, which makes things a little bit more difficult. And something that I recommend that you do when you have an equation with multiple fractions, before you try to solve anything, is get rid of those fractions. You can actually eliminate these denominators by multiplying both sides of the equation by each of those denominators. Or really, you can think of it as multiplying by a common multiple of those two denominators. All right, because remember, the multiplication property of equations says that you can multiply both sides of the equation by any number except 0, and the solution to the equation will remain unchanged. Okay, so we can actually get rid of these fractions and make solving the equation easier if we just multiply both sides by a number that will get rid of those denominators. In this case, we would want to use a multiple of 5 and 2, which is 10, right? 5 times 2 is 10. That would be a multiple of both of those numbers. So if we multiply both sides of the equation by 10, that's going to get rid of those denominators, and hence we will have no more fractions. All right, so just some side work here. Remember, 5 times 2 is 10. I just multiplied those two denominators to get a common multiple, and now we can multiply both sides by 10 to get rid of our fractions. Okay, so here's what we're going to have. We're going to multiply 10 by 4/5 and multiply 10 by this whole side of the equation, all right? Don't just multiply it by 1/2 x, you also have to multiply it by 1. So you're going to multiply it by that whole quantity of 1/2 x plus 1, okay? Always be careful with that. Don't just multiply it by one term, multiply it by all of the terms on each side of the equation. So then simplifying, 10 times 4/5, you want to multiply 10 into the numerator. 10 times 4 is 40, so we have 40/5. And then on this side, you need to use the distributive property. We're going to multiply 10 by both of these terms. Starting with 10 times 1/2 x, you want to multiply 10 by the coefficient of x. So you'll have 10 halves times x, right? 10 times 1 is 10, and you're still dividing it by 2. And then 10 times 1 is 10. So we have plus 10. All right, now simplifying, 40 divided by 5 is 8, and then 10 divided by 2 is 5. So we have 5x plus 10. And so now we have an equation, 8 equals 5x plus 10. It is essentially the same equation we had up here, but without any fractions. It's going to have the same solution as this equation up here because we multiplied both sides of it by the same number. We just changed how the equation looks. We did not change the value of x that would make the equation true. Okay, so now we just have some whole numbers to work with when solving the equation. We don't have to worry about things getting messy when working with fractions. Okay, now of course, you could just work with the fractions if you'd like to. You would still get the same answer, but it might be a little bit more difficult. Most people prefer to not work with fractions if they can avoid it. So that's what we did here. But now, let's actually try to solve for our variable of x. The first thing we want to do is isolate that variable term, so we want to subtract 10 from both sides. That will get rid of that constant. Okay, so let's do that here. We're going to subtract 10 from both sides. 8 minus 10 is -2, so we have -2 on that side, and then 5x plus 0 on this side. All right, 10 minus 10 is 0. Then, to finally solve for x, you want to divide both sides of the equation by the coefficient, which is 5. All right, so dividing both sides of the equation by 5 gives us a final answer of negative 2/5. We can't really reduce that or simplify it in any way. So we have negative 2/5 is equal to 5 divided by 5 times x. 5 divided by 5 is 1. So you have 1 times x, which is x. Okay, so the solution we found here is that x equals negative 2/5. Well, let's check it. Let's see if that makes sense. Let's plug that value of x back into the equation and see if the equation is true. Checking our work, we will get this. 4/5 is equal to 1/2 times x, which we are saying is negative 2/5, and then we are adding 1. Okay, now simplifying, negative 2 times 1 is negative 2, and 5 times 2 is 10. So we get 4/5 equals negative 2 divided by 10 plus 1. And then we can reduce this fraction. Negative 2 and 10 can both be divided by 2. Negative 2 divided by 2 is negative 1, and 10 divided by 2 is 5. So we have 4/5 equals negative 1/5 plus 1. But to add negative 1/5 and 1, we need to get 1 in terms of fifths, which is not too difficult. Remember that 5 divided by 5 would be 1. So we have 5 divided by 5. Any number divided by itself is 1. But then adding these two fractions, since they now have a common denominator, negative 1 plus 5 is 4. So you get 4/5 equals 4/5, which checks out. That is a true statement. And so x equals negative 2/5 is the solution to this equation. Hey there, real quick, before we take a look at the next example, if you find my tutorial videos here at JK Math to be helpful, then I'd like to invite you to join my membership site, JK Math Plus, where you get access to many perks, including bonus content and my exclusive community. The bonus content includes dark mode versions of my videos, extra example problems, and more, while the community is a private space online where you can post questions, have discussions, and study together with me and other members. To learn how to join and see a full list of everything you get access to as a member, you can head over to jkmathematics.com/plus. I'll have a link for that in the description of this video. So if you are interested in becoming a member, feel free to check that out. It's a great way to support me and the tutorials I make, as well as a great way for you to learn math better. But for now, let's take a look at the next example. Next up, we have this equation, 5z divided by 12 minus 1/4 equals 1/6. Okay, so this equation has a lot of fractions. In fact, every single term involves a fraction. And so we probably want to use the same method we used in the previous example. You could try to solve this equation as it is, but you would have to get some common denominators between the fractions in order to combine them when you add a constant to both sides of the equation. And so instead of having to deal with that, let's just multiply both sides of the equation by a number that is going to get rid of all of these denominators. Okay, we want to find a common multiple of 12, 4, and 6. And if you think about it, 12 is a multiple of both 4 and 6, right? 4 times 3 is 12, 6 times 2 is 12, and then of course 12 times 1 is 12. So 12 would be the common multiple. In fact, it would be the least common multiple of all the numbers in the denominators of our fractions. Okay, so what we want to do here is multiply both sides of the equation by 12. We'll multiply 12 by both of these terms, 5z divided by 12 minus 1/4, and we want to multiply 12 by 1/6, okay? By doing that, we will get rid of all of the fractions in this equation, which will make it easier to solve for our variable, which in this case is z. All right, so let's do the multiplication here. We need to use the distributive property on this side. We need to multiply 12 by both of these terms. So we're going to multiply 12 into the numerator of this fraction. We'll have 12 times 5z, so 12 times 5 is 60. So you'll get 60z divided by 12, and then 12 times negative 1/4. That will give you this. We'll have negative 12 divided by 4. And then on this side of the equation, 12 times 1/6 will give you 12 divided by 6. 12 divided by 6 is 2, so we get 2 on this side. And then over here, 60 divided by 12 is 5, so we have 5 times z. And by the way, you could have found this right away up here when multiplying 12 by this fraction. Since the denominator is also 12, we know that 12 divided by 12 would be 1, so you could cancel those numbers out and you would just get 5z. okay? But anyway, over here, 12 divided by 4 is 3, so we have minus 3. And now we're done multiplying by 12. We now have an equation equivalent to this one, meaning it has the same solution, it just looks a little bit different. It's an equation that doesn't have any fractions. We have turned all of those fractions into whole numbers. Okay, and so now we want to solve for the variable of z, so we need to isolate the variable term by getting rid of this constant here, which we can do by adding 3 to both sides of the equation, right? Positive 3 would be the opposite of negative 3. So if we add 3 to both sides of the equation here, what we'll get, and I'm going to have to continue my work up here, what we'll get is 5z plus 0 equals 2 plus 3, which is 5. I'm just going to use an equal sign here. You could continue in your own work with the divider, but at this point I think it's pretty clear what the two sides of the equation are. Negative 3 plus 3 gave us 0, and then we still have that 5z. And so what we have here is 5z equals 5, and so we can solve for z by dividing both sides by that coefficient of 5. So dividing both sides by 5, 5 divided by 5 is 1, so we have 1 times z, which is z, and then again, 5 divided by 5 is 1. So we get z equals 1. That is the solution to this equation. Or at least that's what we found it to be. We do want to check that solution. So let's plug it back into the original equation and see what we get. We'll have 5 times z, which we're saying is 1 in the numerator. So checking our work, we'll have 5 times 1 divided by 12 minus 1/4 is equal to 1/6. All right, now in this case, we will have to get a common denominator in order to combine these two fractions. Right now, we have a denominator of 12 and 4, but if we multiply 1/4 by a form of 1 of 3 divided by 3, then we'll get a common denominator of 12. Okay, so we have 5/12 minus 1/4 times 3 divided by 3. That's that form of 1 that we're going to use so that we get a common denominator. And so that simplifies to 5/12 minus 3/12, which should be equal to 1/6. Okay, 3 times 1 is 3, 4 times 3 is 12. And now that we have a common denominator, we can combine the numerators. 5 minus 3 is 2, so we get 2/12 equals 1/6. And 2/12 can be reduced to be 1/6 because both 2 and 12 are divisible by 2. 2 divided by 2 is 1, 12 divided by 2 is 6. So we get 1/6 is equal to 1/6, which is a true statement. And so z equals 1 is the solution to this equation. Okay, let's take a look at one more final example for this video. All right, so here's our last example. It looks a little bit different than our previous examples. Our equation is 5y plus 9 plus 2y equals 23. So this equation is a little bit weird because we have two terms that involve a variable. We really haven't done that in the rest of our examples, and so you might think that we can't solve this, but we actually can. We talked a little bit about this concept in the previous lesson, that sometimes you will be given an equation that is not fully simplified, right? These two terms of 5y and 2y are like terms. They can be combined. They both have the same variable part of y. So while it looks like this equation is very complicated because it has two variables of y in it, really those two terms can be combined to be one term, and so there would only be one y. There's only one variable we actually have to solve for here. Okay, that is something you always want to do when solving equations. If you see that a variable is repeated, you want to try to combine your like terms if you can, or get your equation in a form such that you will be able to isolate that variable. Okay, we can't isolate y when it's in two of these terms. We can only isolate it if we combine them. Okay, so 5y and 2y, as I said, are like terms, so we can combine their coefficients. 5 plus 2 is 7. So the way that I would rewrite this equation is 7y plus 9 equals 23. Okay, I combined these two like terms to get 7y. And now we have an equation that looks like the other equations we have solved in previous examples. All right, so now the same process applies. We want to solve for y, so we need to isolate that variable term, and we'll do that by getting rid of this constant being added to it. We want to add the opposite of 9 to both sides of the equation, or in other words, subtract 9. So we're going to subtract 9 from both sides, which will give us 7y plus 0 equals 23 minus 9, which is 14. So we get 14 on that side, and so we have 7y equals 14. To finalize our answer, or to solve for y, we then want to divide both sides by 7, the coefficient of that variable term. So dividing both sides by 7 will give us 1 times y, which is just y. So we have y equals 14 divided by 7, which is 2. So we have found the solution to this equation is y equals 2. But let's check it. Let's make sure that that is the solution to this equation. Let's use it in its unsimplified form, just in case we added our like terms incorrectly when we got it in this form. And so if we check our work, we want to plug 2 in for each of those y's. We'll have 5 times 2 plus 9 plus 2 times 2 equals 23. All right, I just used this equation right here, but replaced each of those y's with 2. Now 5 times 2 is 10, so we have 10 plus 9 plus 2 times 2, which is 4. So we're adding 4, and that should be equal to 23. 10 plus 9 is 19, so we have 19 plus 4 equals 23, and then 19 plus 4 is 23. So we get 23 equals 23, which is a true statement, and so y equals 2 is the solution to this equation. We solved the equation correctly. Okay, so always be on the lookout for equations like this. Sometimes they won't be fully simplified, and you'll see two variable terms, but if they are like terms, you can combine them and get an equation that you know how to solve. Okay, and so with that, this was the last example for this video, but if you do want to get some more practice solving equations of this form, I do have more examples available on my membership site, so if that's something that interests you, feel free to look into becoming a member. You can find all the details on my website at jkmathematics.com/plus. If you have any questions, please let me know in the comments, but if you don't have any questions, this is all I had for now, so I will see you next time.